Okay, for topic 2, we're going to review polar coordinates and polar equations, okay? So before we start investigating the graphs of polar equations, let's review how to plot polar coordinates and how to convert a polar equation into rectangular form. I also want to remind you how to convert a set of polar coordinates to rectangular, okay? So for example 2, it says plot the following polar coordinates. We don't have like the polar coordinate system, but that's okay. We can always kind of sketch these, okay? So let's get to sketching. All right, so remember when you're dealing with the polar coordinate system, you have a pole which acts kind of like the origin, and then you have a polar axis which acts like the x-axis, okay? So we start with the polar axis and we open up some angle. Remember, positive angles you open in the counterclockwise direction, negative angles you open in the clockwise direction. So we have positive pi over 4. So that would be like, I don't know, right about here. So this would be about pi over 4, okay? Now what we need to do is from the pole, we need to go a distance of r. And remember, these are always of the form r comma theta. So in this case, r is positive. And remember, when r is positive, you want to go out however many units, r units, along the terminal side of whatever this angle would be. So let's say this is 1 unit, 2 units, 3 units, 4 units, 5 units. So we would say this point right here is the point 5 comma pi over 4. Okay, so I'm going to erase these extra pieces so as not to confuse. Okay, now just for the sake of fun, let's convert this set of polar coordinates to something rectangular. Okay, so hopefully you remember that x is equal to r cosine theta. So x is going to be equal to 5 times cosine of pi over 4. So this is going to be equal to, well, 5 times cosine of pi over 4 is root 2 over 2. So we get times root 2 over 2. So that tells me x is just 5 square root 2 over 2. So that's the x coordinate of my rectangular coordinate point. Okay. Now y, hopefully you remember, is r times sine of theta. So it's going to be 5 times sine of pi over 4. Sine of pi over 4 is root 2 over 2 as well. So we get 5 times root 2 over 2. So we get 5 root 2 over 2. Now, for the sake of fun, let's just kind of eyeball and see what this point would look like if we were to kind of get like an estimate, just a decimal estimate, a decimal estimate. I can't speak to save my life. So let's go to the calculator. So we want to know what 5 times square root of 2, and then we're going to divide it by 2. So we would get about 3.5, okay? So if we went back to our worksheet, we would say this is about 3.5 comma 3.5. So let's say we go 1, 2, well, let's fix that one. So if we went about 3.5 comma 3.5, we would end up at the same point. Now, of course, we don't have graph paper, so I force these two to work. But if you were on like legitimate graph paper, these 2 points would line up. They represent the same location. It's just 2 different ways to find them. One, you use an angle and then some distance along the terminal side or in the opposite direction of the terminal side from the origin or the pole. And then the other one, you just go some distance along the x and then up or down some distance along the y-axis. Okay, now for this next one, let's see what we get here. So in this case, we're going to draw just kind of like what we know is the XY plane, but remember this is our pole, this is the polar axis, and we want to open up some angle that represents 5 pi over 6 radians. So that would be, I don't know, about here. Okay. Now, in this case, r is -2. So when r is negative, we don't want to go a distance of r units in the direction of the terminal side of the angle. We want to go in the opposite direction of the pole. So we're going to go 1 unit, 2 units. So this point over here represents 5 pi or -2 comma 5 pi over 6. Okay, notice we're definitely in quadrant 4. So in just a second, we're going to go ahead and find our rectangular coordinate, and let's just make sure it's also in quadrant 4. So we get x equals r cosine theta. So we get -2 cosine of 5 pi over 6. Well, hopefully you remember on the unit circle, if you are at 5 pi over 6, we have the ordered pair, -√3 over 2, comma, a half. Okay, so what is cosine of 5 pi over 6? Well, it's -√3 over 2. So we get -2 times -√3 over 2. So when you multiply two negatives, they become positive, and then in this case, the 2's are going to divide out to be 1. So we get √3. Okay. Now y is equal to r sine of theta. So -2 times sine of 5 pi over 6. And sine of 5 pi over 6 is 1/2. So we get -2 times a half. Well, -2 times positive 1/2 is going to be -1. And this is definitely in quadrant 4. So if we were to, my setup is a little scrunched today. If we were to go to the calculator, we could see that, well, shoot, I didn't go to the calculator at all, did I? There we go. Oh, why is it not letting me go? There we go. Okay. If we wanted to see what square root 3 is, it is about 1.7. It's a little more than that, but let's round 1.7. So if we go out here, let's say this is 1, this is 2, this is -1. Here's the point, 1.7, comma, -1. So again, I forced it to happen. If we had actual graph paper, you would see that the rectangular coordinates and the polar coordinates, they take you to the same location. It's just a different way to go about it. Okay, so that's one thing that we need to review. And the second thing that we need to review is, if this lets me scroll, let's convert the following polar equations into rectangular form. Okay, so we first have r equals 4. So we have r's and we're going to have thetas in the next example. What we need is x's and y's. And so there are a few things that you do need to remember. We need to remember that r squared equals x squared plus y squared. That's just basically a play on the Pythagorean theorem. We need to know that y is equal to r sine theta, x is equal to r cosine theta. I think those are the only two we're going to need right this second, so let's just stick with those. Now, when it comes to converting a polar equation into a rectangular equation, there are kind of like two tricks we have up our sleeve. One of them is try multiplying both sides of the equation by r, and the other one is trying to square both sides of the equation. So for part A, I like the idea of squaring both sides of the equation. If we were to multiply both sides by r, on the left, I would get an r squared, which is great because I could convert that to x squared plus y squared. But then on the right, I would just have this like random r and I wouldn't know what to do with it. So if we can square both sides, we'll get something we can work with. So we're going to square both sides. That's going to give me r squared equals 16. And then don't forget, r squared is really equal to x squared plus y squared. So let's do that substitution. So we get x squared plus y squared is 16. And hopefully your Math 171 algebra brain is like screaming right now. What is this? This is a circle centered at the origin with a radius of 4. And let's kind of think about that. Pretend this is a perfect circle. Definitely not my worst effort. I'm proud of this one, okay? So this is a circle centered at the origin with a radius of 4. But let's think about this right here. Let's think about the original polar equation. Okay, in this polar equation, we're told that we're always going to have some distance r from the pole, okay? But it doesn't really give us an angle. So it doesn't matter what angle we're given. We could have literally any angle here, and we're going to be some distance of 4 to the pole. So again, it doesn't matter what angle. The angle can be quite literally anything. We just know that we're always going to be 4 units away from the pole. So this right here, if you think about it, R equals 4. We know the distance from the pole. We have no idea what the angle is. We have free reign. The angle can be literally anything we want it to be here. We just have to always make sure that we are 4 units away from the pole. Okay, so that one should kind of make sense that that one's going to give you a circle. So if you ever see anything of the format, R equals just a number, it's going to be a circle centered at the pole with whatever radius. Okay, now for part B, we have R equals 3 times secant theta. Let's think about this one. We have some substitutions for sine and cosine. We don't actually have a substitution for secant, but we do remember that secant, hopefully we remember this, it is 1 over cosine, right? So let's just rewrite this to start with in terms of cosine. So I'm going to say, okay, we have R equals 3 times 1 over cosine theta. Okay, well, if I were to square both sides, that's not going to do anything for me. If I multiply both sides by R, I'm going to have this random R on the right-hand side that's not really going to do anything for me. So what I like here is like, let's just multiply both sides by cosine and just kind of see what happens. Okay, so let's multiply left and right by cosine. Okay, well, on the left-hand side, I'm going to get R times cosine of theta. On the right-hand side, cosine divides by cosine, so that's just going to be a 1 right there, and I'm left with 3. Well, let's think about this a little bit. We have a substitution for R cosine theta, right? R cosine theta is really x. So this is really x equals 3, which is a vertical line through x equals 3. So let's think about this one. So let's go back to this version of the polar form. Okay, we have R cosine equals 3. So basically what this one is saying is it doesn't matter what R is, it doesn't matter what theta is. No matter what we plug in for R and theta, we're always going to get a ratio of 3 for cosine. Okay, so R times cosine of whatever, we're always going to get it equaling 3. Okay, so no matter what angle, we get, no matter what ratio we get for cosine, when we multiply it by whatever R is, we're always going to get 3, okay? So that kind of tells you that you're going to get this vertical line that is running through the x-axis, okay? Let's see here. Okay, so that's it for this one. So it is like storming really bad outside. I hope I don't have to plug my computer in soon. Anyway, so make sure you remember how to plot polar point or polar coordinates. Make sure you can convert between polar and rectangular coordinates, and make sure you know how to convert polar equations into rectangular, because there are definitely situations where the polar equation maybe isn't as easy for us, but the rectangular form is super easy for us. Like, we know circles, we know vertical lines, okay? So the rectangular form in both of these cases is kind of easy for us. There are going to be other situations where the rectangular form would be like absolutely bananas and we would want to stick with polar. We'll talk about those later. But that's it for now. In the next video, we're going to start looking at the polar equations officially, okay?